Olive, and today we're going to be going over how to teach LCM and GCF using the ladder method. Let's look at the numbers 24 and 36. So now we want to find the LCM and the GCF. Start off by writing the numbers on one line, like this. Then make an L, ladder method. Now we're going to find the smallest prime number that goes into these two numbers. In this case, it's 2, the smallest prime number. So we have 2 into 24 is 12, and we have 2 into 36 is 18. Then we do it again until we have all prime numbers. So we make another L. Again, the smallest prime number is 2. So we divide 2 into 12 to get 6. We divide 2 into 18 to get 9. Again, we make the L. Now, the smallest prime number that goes into 6 and 9, it's not going to be 2, it's going to be the next one, 3. Divide 6 by 3 to get 2. Divide 9 by 3 to get 3. Now we have all prime numbers, so we know that we finished. We're at the end. To find the LCM, we make an L. And we multiply all those numbers together on the L. So LCM is going to be 2 times 2 times 3 times 2 times 3, which altogether is 72. The GCF you find by going straight down this line. That's going to be 2 times 2 times 3. 4 times 3 is 12. And that is how you find LCM and GCF using the ladder method. I'm Rachel, and thanks for learning with us today.
Alright guys, so I thought that was a nice little video to show you one way you could find GCF and LCM. Let me focus this real quick. Alright, obviously this is going to be the topic that we're going to discuss today. So we are talking about GCF, LCM, and you can do it by hand. There definitely is a way to do it. Like, you know, that ladder method is a great way that you can go ahead and find your GCF and LCM. I'm going to show you today via graphing calculator how we can do the same thing with numbers. Okay. The only catch is you can't do graphing calculator with variables, but there's a quick and easy, effective way to find that. So let's get to it. Okay. Describe, let's see, GCF and LCM. First little part up here, and I'm going to jump around a little bit, but we'll start off here. Describe the difference between a monomial and a polynomial. Provide an example of each. Okay, a monomial is when you're talking about a algebraic expression consisting of one term. So a monomial, here's a quick example over here to the side, would be something like 3x squared, just one term. Okay, just, you know, there we go, 3x squared, boom, done. So one term. But however, a polynomial is multiple algebraic expressions. So multiple terms. Okay? So you might look at something like 3x squared plus 4x plus 1. Okay? Something along those lines. That one more specifically being a trinomial. But alright. Factors of a number. The numbers that multiply together give you the original number. So when we think about factors, if you think about something like 6, you could have 3 times 2 or 1 times 6. You can have multiple sets of factors for each given number. Prime factorization, finding which prime numbers multiplied together to make the original number. Remember, a prime number is a positive number greater than 1, which only has the factors 1 and itself. Alright. So for the first part here, it says factor the following monomials completely, including the variables. What they mean by this is rewrite this as different terms as all prime numbers. So for 6, you're looking for, we couldn't do 1 and 6 because 6 is not prime, but you could do 3 times 2 because they're both prime, and we can break up x squared to be x times x. Okay? Good. Something like part B, 18xy cubed. 18, you could do 9 and 2. I'm going to do this up here real quick. But then you can break down number 9 again to 3 and 3. So you could have 3 times 2 times x, and then we have y cubed. So there's 3 y's. Okay? So again, this is your prime factorization of it. You're just figuring out all the prime numbers that go into it, and then for your variables, you're just breaking it up to how many there actually are. Okay? Now I'm going to jump down a little bit, like I said. I'm going to jump around a little bit. Greatest common factor, aka the greatest common divisor, GCD, GCF, as we oftentimes hear it. It's the greatest monomial factor that can be factored into the terms of a polynomial. When finding a GCF of a set of monomials, we will factor each monomial, and the values that are common will make up the GCF. Alright, I'm going to share with you guys down here a little bit easier way to do this, because you do have the luxury of using this graphing calculator when you are taking this exam. So we're going to show you as many tricks as we possibly can, as I'm trying to reset this calculator and I'm having a brain fart, so please forgive me. Okay, so you're looking for the GCF of 8 and 10. Now what you have to do is do each thing separately. So I'm going to start with the numbers, 8 and 10. The GCF here, what you could do is you could hit the math button. You go to the right one, and I'm going to scroll down until I see GCD, greatest common divisor. Okay. If I hit enter, I'm going to type both these numbers in with a comma in between them. Ta-da! 2. So I got 2. Now for GCF for variables, we go low. What I mean by that is, look at your variables here, x cubed and x to the first power. Which one's smaller? Okay, lower one. Lower one for this would be x to the first power. So we write x to the first power. Y squared and y cubed, which one's lower? Y squared. Done. See how simple this is? Okay. Now I showed you guys this calculator method, but I need to give you a little like asterisk here. If you're going to choose to use this method, it doesn't do 3 terms. So if I hit second enter, I pull back the last thing. If I try to type in 7, 28, 14, your calculator will give you an error. So what we have to do instead is you have to take your time, be a little patient. Okay, and let's see here. Do 7, 28 first. And I am off today. Okay, the GCF between those two is 7. I don't know why all of a sudden it got really, really dark in here. Okay, there we go. Needs a little better. Okay, so now I'm going to do the same thing, but now I'm going to use 7 and 14. So the GCF between these 3 numbers is then 7, 7. And x cubed x, x to the 4th. Which one's the lowest one? Just x. Done. Okay, that's all there is to it. Having really trouble with lighting today. Sorry about that. Okay, on the back. Now, much the same. I'm going to kind of jump down here to number 3, just to kind of show you guys the examples. Find the least common multiple of the terms. All right, here, I can do the same idea with this calculator if I choose to. I can hit math, go to the right one, go down, and instead of GCD, I want LCM. So I type in 3, 10. I'm on number 3, part A right here. We get 30. Now here's the difference for GCF and LCM. LCM, we go high. So for x squared and nothing, there's no x's here. Which one's higher? The x squared is higher. There we go. Okay. Let's take a look at part C. Okay, over here. I know I'm jumping around, but just to show you guys as much as I can. I'm going to, again, you can only do the calculator for the numbers. So if I hit second enter, I'm going to type in 18, 24. My GCF is 72. Watch how simple this is. M squared or m to the 5th. M to the 5th is higher. N cubed, n squared. N cubed is higher. Done. Okay, wonderful. Alright, here are 2 nice word problems for us to take a look at. A math teacher and a science teacher combine their first period classes for a group activity. The math class has 24 students and the science class has 16. The students need to divide themselves into groups of the same size. Each group must have the same number of math students. Find the greatest number of groups possible. how many students from each class are in each group. Alright, so what we're going to take a look at here is we're going to find your GCF. You can't go high with this one because think about it, you only have 24 students, 16 students. If you try to do LCM, you go very, very high. So if I did math GCF or GCD of 24 and 16, I get 8. Alright. The students need to divide themselves into groups of the same size. So we could write GCF 24 and 16. Find the greatest number of groups possible. Alright, how many students from each class are in each group? Okay, so we know that there's 8 groups going to be formed. Alright, so what we need to do is find out how many of each students are in each group then. So what we can do is take 24 and divide it by 8. Because we have 24 math students, that means there's 3 math students per group. And then do the same thing here with 16. Take 16 and divide it by 8, and then we get 2 science students per group. Okay? Therefore, there are 4 students in each group. Okay, 3 math, 2 science, and 8 groups total. Which makes sense because if we do 8 times 5, we get 40. If I added 24 and 16 together, we get 40 total students. Okay? Alright, number 5, Mr. Drake bought muffins and drinks for a breakfast meeting. The muffins were sold in packages of 12 and the drinks were sold in packages of 18. What's the smallest number of packages each item that Mr. Drake could have bought and still had the same number of muffins and drinks? The key word here being what is the smallest number of packages for item that Mr. Drake could have bought? LCM, least common multiple. So here we're going to do math LCM 12, 18 and we get 36. Okay, so the LCM of 12 and 18 is 36. So we got to figure out how many packages of muffins were bought. Well, we can do 36 divided by 12 to get 3. So 3 packages of muffins. And then we could do 18. Oops, sorry. 36 divided by 18 to get 2 packages of drinks. Okay, so there we go. What's the smallest number of packages of each item? So 3 of muffins, 2 of drinks, and we're all set. Okay, hopefully this makes it a little bit easier for you with GCF and LCM. Feel free to practice via the Khan Academy if you need be. And as always, feel free to ask questions to anybody that needs help. Alright, good luck. We're all counting on you.